Right, hello. Let's see. Yes. So we were working yesterday on looking at how to do all the transposing, moving the hunks around, and I tried implementing it later that evening, and doing so I discovered something, and like it's been the core of the confusion. It's like we get this diff from Git, which is this hunk, and it describes like declaratively what changed in the file. And what I wanted to do is I wanted to use that information to produce what operations I need to apply to go from the previous version of the file to producing the final version of that file. Basically applying the diff. But I need to do it in steps, right? Because we're going to move these hunks around, and we should be able to split them up, and we need to like dynamically apply this. Yes. So, but we also want to show like what changed. Like we actually want diff information as well. And I tried to do both. But what I landed on now is that I'm not thinking about the diff at all. The only thing I'm doing is I'm converting a Git hunk into a hunk represented by actual operations. And the operations are even like, it's sequential, meaning that even though you say, so let's imagine you have like 2 removals in one file. Like in terms of the Git diff, it says that you removed on line 2 and removed on line 7. But when you apply that as operations, you first remove line 2 and then you actually remove line 6. So that's something this conversion now does. So a hunk now doesn't have like old and new and all that stuff. It just has a start and an end, which is also a better user experience because a hunk doesn't like flip up and down as you flip between them, like the old and the new version. And also the operations can just be applied directly. So yeah, by the way, I need some music here. Let's see. By the way, I have a couple of ideas on the, let's see, family scrum thing. I'm pumped to dive into that project again. Let's see. Yeah, I just need some. I have to have music in the background. Okay, so if you look here now, we have. I'm currently working on this because now what I'm doing, I'm reading the operations to figure out change indications. So that's what we're going to fix together now. But as you can see, now this is actually based on operations. And it shows this correctly. It shows it runs this correctly, and I can move them around, and it still kind of shows it correctly, like it applies operations correctly. That's the main thing. And then we're going to fix the indications together now. And it even, I believe, does this correctly. You see, get the old and the new version, stuff like that. Okay, so let's just go in and figure out how these indications should work now. Because, and I think we should just, I think instead of like get removed lines, I'm thinking I think we should just call it get diff, because now we're looking at how does it actually, I don't think it, yeah, we don't even like it's even not working at all. So I'm just thinking about how we should do this. Should we go and extract like a proper diff so you can actually do a lookup? Yeah, maybe we should do that. And let's just call it get diff, because then what we're going to get is all the lines. Or should we have like get removed lines? How should we do that? Should we have, because we're showing two different versions. We're showing the final result of the file and the previous version of the file. Should we have one diff representing what to display in the, yeah, I think we have to do that, because the final representation of the file doesn't care about, well, it does. Not a mind-bending. Another mind-bending one. How are we going to produce this diff? Let's look at the result of this first. So we have, this is how the data structure looks like. So let's imagine we're on this one, and it should indicate, so this is the only thing. So these are the operations. We have a replacement of a couple of lines, which is start 21 plus 3, 24, which is here. And then we have the same here. Sorry, here, because it adds a comma. And then we have an addition on this one. So how should that diff look like? Yeah, I think we should just bring this array, because what can happen here is that, as you can see, it's an array now where you have the offset, which means that the offset can be the same on two different operations. I think. Can it? Maybe it can't. Okay, we just have to explore this. So let's just create a file called getDiff. Sorry, a function called getDiff, and then you get the hunks, prhunk. And what we're going to do, we're going to have diff, which is a record of, it's actually a number, and pr operation. Let's see. Maybe we can even make this better. We can say hunks.reduce, and we're going to produce a record of number pr operation. And like that. Give me a pr operation, and this is the hunk, and then we're going to I think we can just add it. It's kind of weird that we do it this way, but anyways, yeah, so we're just going to go through line up. We can even say offset operation of hunk.operations. Like, the code got even simpler this way. So again, we've simplified the code, but I think we're just going to yeah, no, I don't like using reduce when we're not being pure. So we're going to do this instead. We can call it const record number pr operation, and then we're actually going to go through for hunk of hunks, and then for operation offset of hunk.operations. This is what we're going to do, and then we're going to return that diff, and we're just going to say diff hunk.start plus offset equals operation. That's all we're gonna do. And then in here, we're actually going to just call it diff. We're going to say get diff. And now this diff, we should be able to do this. And here we do this. Line operation. Oh. Where's undefined? Let's see how this looks. So it didn't actually show. Oh, wait a minute. We have to grab. Oh, that's weird. Oh, sorry. Yeah, because I'm actually setting the actual line number. But since this is operations based, I wonder actually how this is going to work. Yeah, as you can see, it's correct for the new one, but it's not correct for the old one. So I think we need to have two different. I think we need to have two different versions. We need one which is the new. Because it will have the correct. As long as it's like additions or replacements, it's okay. But when it's removals, it gets off. Because the removals aren't happening in the old version, right? So you have. Yeah, so I think we actually still need the removals. Oh, let's. So we have get const diff. Removed lines is get removed. What did I call it? Get removed lines. And that's what we're going to use on the old one. What's that? Yeah, exactly. Okay. So that's perfectly fine to me. So what's happening here is that since it's a removed line, we don't see it here, but this is actually a replacement. So I've highlighted that as strong yellow. And what you also see here is that the hunk doesn't actually change. So you still have the same area of focus. It's the contents of the hunk that changes. Yeah, and this is like especially nice. You see that these two lines. So that's what I'm thinking about now, is that when we do when we do this, I'm thinking about actually not adding the removal on the actual line. I'm thinking about actually showing the new version, like going through the new version of the file, but then do like a reversed. So if there's a replacement, I'll do a reverse replacement. And if it's an actual removal, I'm not sure what I'm going to do there, but kind of add it on top or something. or next to it, at least so it doesn't actually take up any space. That's the thing. I don't want it to take up a line on its own, because then the hunk bumps. Like, it's harder to see actually how things changed. But that's something we can play with later. The important thing now is to make this stuff actually work, the operations work. And if I take this now, I move it right, everything's not showing correctly. So let's start reviewing the code for that. Because I did start implementing the stuff. Oh yeah, now it even breaks here. That's interesting. Yeah, anyways, let's look at the code. Oh, sorry, I haven't actually fixed this. That's it's not that weird. Get line, change code. So these are actual operations. So this is not operations. This is actually oh, do I actually call it get line hunk dot? Okay, I'm calling it operations. That's fine. But what I'm actually getting here is PR line operation, and we'd rather do this, and the operation is actually like this, and then that's at least okay. Let's see what happens now. Let's move these two. Yeah, so that was basically the problem. I haven't updated that yet. And let's try moving all these over to the other commit. Yeah, and it's still correct. So you see that? We're actually getting closer to something that works. But I think I know something that doesn't work. And that is if I now were to move this one over here. So it works here, but now you see it's broken here, and that's probably the way I calculate this. So what's funny to me is, let's see if we can reproduce it easily. Yeah, so let's look at that logic, and let's see. Yeah, so what I think is that we're transposing this one correctly, because it doesn't transpose like the actual hunk we move, but then we also have this other one, or the one we leave. So this is how we kind of figure out how to transpose the actual hunk that we move. Let's rename this. Move hunk right transpose, get move hunk left transpose, and let's see, when we're moving right, so this is the logic I implemented. It seemed that I could actually simplify what I described in the Excalibur. Like I said a lot about origin SHA and stuff. But I actually removed a couple of checks because I don't think they're necessary, but that's something to explore. But the way this works is that I'm basically transposing the hunks, and I do that by checking, just going through the hunks unordered, or in the order they are in terms of their original position in the array. And I check if it has been moved left or right. And if it's been moved right, let's look at that because it has a bug now. I go and figure out how much does that need to transpose itself. Like how does the hunk being moved, being affected by this moving to the right, and then it's yeah, maybe we should. And this is the transposition for the others. How are the other hunks affected by this hunk being moved? Yeah, let's just call it this for now. And now what we're doing is that we're going through everything and we're checking. This hunk that has a start that is more... Oh, maybe it's because they actually end... Okay, I think we should do this instead. I think maybe these two hunks happens to start and end on the same line, which is why it wasn't taken into account. Maybe. Let's see. No, that wasn't it. So for some reason, like nothing happens to this one, I believe, which I find to be a bit weird. Anyways, so let's see if it actually gets transposed at all. What does it actually say here? Yeah, it doesn't actually transpose. What? Oh, sorry, it's moved right. That's interesting. Is moved right. The SHA index is more than the origin SHA index, but why doesn't it hit this? It's as if... Oh, maybe it's actually how I produce the thing. Oh, yeah. I think I know what's the problem. I'm not actually including... Yeah, this is also a fundamental flaw, because I'm only including SHA indexes. I'm not including SHA indexes that are... I don't think I should check the actual SHA index. I should check the origin SHA index. Let's try that. Because I want to include all hunks. Because I need to transpose, I need to include all hunks. Yeah, exactly. Yeah, now I see. Okay, and that's why I removed some of the checks up there, I think, because I concluded that I will never have a SHA index that's more than the target SHA index, but I will actually have that. Because we're checking for origin SHA index, which means we can move actually beyond... Yeah. Okay, this is interesting. Let's see what actually happened. Okay, so now it actually started. Something happened. Let's see. Oh. Yeah, and I think I know why things started to fail here now. Okay, let's do a simple one. Okay, this one failed. Origin SHA index. Wait a minute. is less or equal to SHA-index. Oh, okay, so I think I need both. So if the hunk SHA-index is less or origin, I think I actually need both. Yeah. Okay, interesting. Cool. Okay, nice. So that worked. Let's try the one that didn't work. Okay, interesting. Interesting. Oh, now I really have to think. What am I doing here now? Because now this line should have been produced. So initial content is transposing hunks up to SHA-index. But now hunks up to SHA-index also includes later. No, 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 no. Don't wake up yet. No, this is, no. Please. We're kind of getting into the same issue where we need to transpose and okay, I think, let's see, apply diff to lines. We only want to apply those that are actually, because now we're adding everything, right? But we should only apply, I think this signature needs to change because now we don't only have the hunks. Now we actually want to, like, we're including hunks that is there only for transposing. But when we apply, we don't want to apply those that we only use for transposing, like beyond. Yeah, so when we do transpose hunks, this one should only contain. Oh, this is so interesting. You know what we should do? I think, yeah, wait a minute. Transposed hunks. We'll, whenever we're going to build the contents, we're actually just going to go through all the hunks and we're going to transpose them. And with these transposed hunks, now it's transposed, so now we can actually use this logic. And we can actually, we don't transpose again. Now we can actually do what we originally did here. So we just transposed the whole freaking thing first. And then we have hunks including. So when we build the initial lines, I actually think this will even work now. So this is hunks up to SHA-index. Why do I have both of them? Okay, but let's just hunks on SHA-index. Maybe this actually starts working again now. If not, I will figure that out as well. Yeah, see that? That's still working now, like the old version of this. Oh, but this breaks completely. I wonder why though. What if I do this now? Does that fix it? No, that doesn't actually fix it. I wonder why that started failing. Why can't I transpose everything? Is it because I'm hunks up to... Oh, transposed hunks. Okay, I'm going to try again. Initial lines. And then I'm going to do this. I wonder why that fails. Because this is actually correct. Well, even the contents are wrong. Well, that's the biggest issue here. I wonder. So I don't quite understand that, because now so the old content is actually correct. It shows the old version of the thing. And when I then go in and I apply now go in and apply, but this was transposed from line 21 start. Wait, this is weird. Start 20. It doesn't start on 20, it starts on 19. Why does it start on 19? What? Yeah, start 21, 21. And then I move this over and it says start 20. But it is indicated on 19. How can that be? Oh, wait a minute. Am I? Yeah, and I'm sorting it. Start one, remove one line. So now you should start on 20. This is correct, which is what confuses me. this isn't reflecting the data. It says start 20, but it's on 19. How can that happen? But more so the operation. Because now it says operations. Yeah, it should be 20 plus 3. That's where it should do the replacement, but that doesn't happen. Let's take a look at the actual transposed hunks. Transposed and the actual hunks on SHA index. This is fishy. So the actual transposed hunk says now I have a feeling it happens twice. I have a feeling it's happening twice. So here it's 20, but here it's 19. Yeah, there's something fishy going on here. So when I'm transposing the whole thing, why is that different? By the way, I don't need any of this anymore. Why is that different? Hunks up to SHA index. And this is already sorted, so this should be okay. But why does it okay, let's just look at it. Console.log transpose moved left. Transpose other. It seems to happen twice, which is the weird thing. Oh, wait a minute. Is it because... Oh, I think I know why. It's a hidden thing. We are assuming that the hunks we get in here... Yeah, I think we have to slice it. We have to make a copy of it. Yeah, that's it. Yeah, we can't, yeah, because it mutates the array. Okay, nice. I'm still happy. Can we move all of these over? Does that work? Yeah, that works. Okay, nice. So now we have, this is nice. This is more efficient. It's simpler. Transposed hunks. You know what? We should just we should do that inside here instead. Hunks equal hunks slice. Oops. Can there's just, was it just slice or do I have to do? I can't remember. No, it's just slice, right? Yeah. Make a copy, because we're actually returning. Yeah, cool. So now we have that. We don't need to rebuild the full contents. We can now do all this shenanigans. Okay, so now for the grand test is to move this over here. Wait a minute. There's already something wrong here. This should have... Yeah, moving that over, you see we're missing some contents here. Okay, so but that doesn't matter. Let's see why this happens. So let's console.log transposed hunks, and we're also going to log hunks on SHA index. There we go. Okay, so first of all, let's look at the actual array. So it has a start of 1, and it does only this operation, which I find funny. So maybe this one's... Oh yeah, you see here, this one's completely wrong. Okay, so let's look at that logic. So when we move something right, we go in and we look at all the hunks, and we see, do we have anyone starting after the one we moved, which is this one, and is the origin SHA index less or equal I think this should actually be less than moved hunk SHA index. I don't think it affects this one, but now I think we're just getting the wrong... Yeah, transposed by -1. And that's not correct, because we moved... Huh? So you see now the content is correct, but we're saying that we actually have one less line, which is not correct. It's actually the opposite. How do we know that? Do we know every time we move right? Yeah, I think this just needs to be reversed. Yeah. Exactly. That makes sense to me. This is pretty awesome. And then we can move. Still happy. No, it builds the contents wrong. You see here? Contents are still wrong. Okay, but we're getting really close now. Really close. Okay, so let's take a look at what happens there. So is even this content correct? This is correct. Oh, if I move this over, oh, it starts breaking. Okay. Why does it start breaking here? How is that possible? Because now the old... So what it does, it takes this content. Oh, even that is wrong. How can that be wrong? But then this should be wrong as well. Oh yeah, okay, so yeah, it was the... Okay, cool. So it was the yeah, it was the moving of the thing over there causing this one to break, and then this one breaks as well. Why does this one break? Is this one even wrong? Oh shit. Oh, that's interesting. How could this one break by moving this one? That's very interesting. Okay, so then we okay, because that shouldn't be affected at all. So we're transposing something we shouldn't transpose, but that's good to know. So what I think we should do is we should move it again, then we should look at the transposed array. We're going to look at, yeah, it transposed this one. Why did it transpose that one? So if the origin SHA index is less than the moved hunk, so we're actually including the other one now. We have to make sure that we stop so if the origin SHA is less, so what we want to do, we want to transpose anything that's later after the current within same SHA and up to where it was moved. Is that consistent with what we said yesterday? All entries after the hunk and from its origin SHA, excluding its current SHA. Yeah, exactly. So it needs to be within so how do we express that? So it's within the same yeah, because now we have the okay, so we only want to transpose if the SHA index of the hunk we're looking at is more or equal to the moved hunk origin SHA within the same SHA and up to where it was moved, and untransposed yeah, I think this is wrong. I'm just expressing this wrong from the excalidraw. So it needs to be more or equal to and less, and the SHA index needs to be less than where the moved hunk is right now. I think that's correct. Let's see what happens now. Yeah, so now this one wasn't affected by it. Oh, wait, what's happening here? Oh yeah, sorry. Yeah, it's because of the scrolling. Interesting. Okay, how does this one look? This one's still happy. It shows the correct content. And then this one also shows the correct content now. And we have the change here. Nice. Let's try moving another one. Now it fails again. Okay, so what actually happened now? Now we moved right, which means we have to question how this one should be transposed. Well, first of all, the contents are wrong. So we didn't transpose the hunk itself correctly. So let's look at the logic again. So get move hunk right transpose. So what we're looking at here is if the hunk start is less than the moved one, okay, so that is this one, the top one. And if the SHA index is more and the SHA index is more than the origin SHA index, yeah, this should hit right home. Let's look at what it actually... Oh, I didn't have a transpose by... Oh, no. Okay, let's just refresh. Let's move you over. So now we say transpose by -1, -0. That's interesting. This was transposed by -1. Yeah, and this is where I think the Excalibur draw failed. Because we shouldn't do it if the origin SHA is actually the same. Because if the origin SHA is the same, yeah, we have to also check. I think I actually do that, or I did do that. And hunk.origin. So the thing is, if we move over, and we shouldn't transpose it if they come from the same origin, because then they are already, they have the relationship they should have. It's only when they differ. So, and hunk.origin SHA index is not equal to move hunk origin SHA index. Yeah, this is a tricky thing, because okay, no, that works, because here we're saying, okay, move hunk right transpose. Yeah, everything. Oh, but this is, yeah, find every hunk starting before the moved one that has a SHA index later than what we actually want to do here. Starting before the move on that has a SHA index later than its origin. Is that correct? I don't think that's correct. What do we actually want there? We want this thing to be, when I move this over, yeah, that one was okay. When I move this one over, so yeah, this is interesting, because if I only move this one, I want it to be transposed by whatever came after this. Yeah, I'm doing something wrong here. So if I move this over, no. What the fuck? If I move, so this got transposed now. Everything later than. Oh, I'm cold. What time is it? Hopefully Oscar will sleep. We can wrap this up. That would be amazeballs. I'm trying to wrap my head around this. So when we move this one, okay, let's do the opposite. Let's only move that one. That should be easier. So that actually worked, because now it got transposed by the previous one, where I even had this logic in there now. Which should happen. So if the SHA index that has a SHA index later than the origin SHA index, and then include the current SHA. No, this doesn't make sense to me. That means nothing changed here. I should probably have done this test driven. God damn. So how does this actually look like now? We have this starts on 6, and if I move it, it still starts on 6. And it displays correctly. Why does it display correctly? Well, it's because the first one has already been applied, of course. Yeah, we don't, yeah, which is why we don't care about what's before. Why do we, did I write that? That we should find the ones before? No, after the hunk end. Yeah, exactly. So this is wrong. Find every hunk starting after the moved one that has a SHA index from its origin SHA, excluding its current SHA. Yeah, I don't think that's correct though, but let's see. Where the SHA index from its transpose the other hangs by, oh wait, no, this is, fuck, this is transposing the one we're moving by finding all entries before the hunk start from its origin SHA, including its current SHA. But doesn't that mean it will find this one? And then it will transpose it. That's what I don't understand about this logic. Let's remove this one again. I think we have something else excluding that thing. Yeah, transpose by 0. But with this, this explanation, transpose the moved hunk by finding all entries before the hunk start from its origin SHA, including its current SHA, and transpose. That's not correct. We shouldn't transpose it. Because those things are already applied. What we want to do is, when we move something right, we want to look at what's after that. So basically we want to find everything between where it was moved from and to where we moved to. I think this is the tricky thing, because we want to basically, we don't have a good way to like express. So it's basically, if we are on, yeah, maybe this is where I'm going wrong, because if we were to move 5 over here, it basically means on the origin SHA, find all hunks after the start of 5, and then find all the hunks when you get to the actual point of the SHA here. I think I have to think about it in those terms. It's like, which is why this visual really helps. It's like, when we move a hunk left, we want to subtract, we want to figure out from that point what hunks are, hunks on, and this is the thing, we can't actually use origin here. Because you might not actually move from origin, you might move from somewhere else. So that's something I also think is wrong with this logic. We're assuming that you're moving from origin. But you kind of are. Yeah, you are actually, like, because we don't actually store every step that you move. So you always move from origin in that sense. Okay, so is hunk before an origin? Okay, that means, does this hunk start, is this before the move hunk start? And is the hunk SHA index equal to the moved hunk origin SHA index? That means we should include that in our change count, and then it's is hunk after, is hunk before, yeah, is hunk before old, let's call it position, is hunk after, well, is hunk, what we really want to describe is like, is hunk between the old and the new position? So maybe we could before open is hunk after new position. Let's just call it that. So if this hunk start is more than the moved hunk start, and the hunk.shIndex is more or equal to the moved hunk shIndex, and hunk.shIndex is less than the moved hunk origin shIndex. Yes. So this describes, so if we move something from, so if we move this one over here, it would, this one would hit number 2 here, because that's before the start of this one, and its origin shIndex, or its shIndex, is equal to the origin shIndex. But I'm not sure it should be origin, because we're going to move it maybe multiple. No, because that should be captured by everything else. Okay, so that captures the actual place you moved from. Wait a minute, let's just move this over here, just to reason about it. Capture this one. And then what we do now is that we look, yes, this is the thing, like we shouldn't really use the start here. Oh, yes, exactly. Is, we need 3 ones. Is hunk before in origin? Is hunk between target and origin? And then is hunk after in target? Okay, yes, of course. Is hunk between, so this would be so yeah, so let's build up something here. Let's do the 5 over here. And let's do like a removal in line 8 or something here. Okay, and we want to move this. So first, okay, so let's say this is the thing we actually move. We want to move this over here. And all the hunks that affects this is 8, 5, and 2. Right? So to find the 2, and that's the thing, like sometimes we care about the start, if it's before or after the start, but sometimes we don't. So in the origin, we care about that it's before the start. In the in-between version, we don't care about the start because all of the hunks affects the transposition of this one. But then at the target, we only care about the ones that's after that thing. So is hunk between target and origin? That would be before. Yeah, before in origin. That if the hunk start is less and it's in the origin. Is hunk between target and origin? That means hunk.shIndex is more than the moved hunk shIndex, and the hunk.shIndex is less than the moved hunk shIndex or origin shIndex. That would be this one. Is hunk after in target? That would be hunk start is more than moved hunk start. And we could say hunk.shyIndex equals moved hunk shyIndex. And what we would do here is we would say is hunk before in origin, or is hunk between, or is hunk after. And I wonder if this is the same for both. So let's imagine that we do the same thing here. Well, it's almost the same. Yeah, which is the case for the other one as well. But I love how we were able to express this. Is hunk after? Like we just have to... Okay, let's be explicit. Is hunk after in origin? Is hunk between target and origin? That's the same. Is hunk before in target, which means it's less than the moved hunk. Yeah. Okay, this is going. Does this even work for the simple use case? No, it didn't. Which is okay, but now it's easier for us to reason about this. So when we now did that simple move, god damn it, we did this very simple move of, let's say 7 is over here. Let's imagine 2 is here and 1 is here. And there was like an addition, let's move back 5 here. So we did this very simple move over here. And it should only be transposed by this one. Should it be transposed by this one? Because that's how the logic works now. It tries to find all the hunks between which I find peculiar. So isn't that correct? That it should actually look at everything before in origin? That makes sense. Is hunk after in target? Shouldn't that transpose? Oh, wait a minute. This is, yeah, it's, oh, no, it's not correct what I said. It does actually care about the line. So we don't care about, so looking at this thing, it only cares about, so in between, it only cares about stuff, it always only cares about stuff that happened before it, moving left. It doesn't care about anything happening after it. Is hunk before in target. So again, is hunk before, between, and I think we can just be this explicit because it helps reading the code. So here, if we're going to move this one, it looks at this one. Is it before here? No, it's not. But is it before here? Yes, it is. And then it fails. And it fails because it's the same origin SHA. Because if it's the same origin SHA, it's already been transposed. Wow. I don't think tests would. I have to have a mental image of how this is supposed to work before I can write the tests for this. But is that... Should we also check? So we don't care about those after. When we're moving left, we don't care about those after, and we don't care about the ones that has the same origin SHA either. Let's try that. Okay. Yeah, so I guess we need to apply the same logic to... So when we're moving... Okay, so let's see. But when we're moving right... So if we were to move this one over here, we do... So maybe that's the difference. Like when we move something left, we kind of... I guess you can see my hand. But we kind of move stuff unrelated to, like, it's kind of like cutting off all the lines after it. We don't care about those lines. Because those lines, yeah, it just doesn't matter. But when we move right, it's... No, it's the same. It's exactly the same. No, it's not exactly the same. God damn it. What's... We care about the lines. So if there was a removal on 8 here, and we move 5, do we care about that removal? No, we don't, because it still happens on line 5. Well, no, it doesn't. Because now 8 has been removed when we go over here. What's the different? Why is moving right and left so different? What if this 2 was a green one? Would that change it? Is it adding and removal that's causing confusion here? So if 1 was here, and we move 2 over here, yeah, that should actually happen on line 1, right? But now with this logic, Yeah, no, it does transpose that now, actually. Yeah. But yeah, what about this one? Oops. Yeah, let's say that's an addition. We move 5 over here. We need to transpose that so it's now affected by everything after it. But why? Yeah, just like isHunk before in origin. Let's copy isHunk after in origin. We already have that now. isHunk between target and origin. isHunk before in target. But in this case, we do. Yeah, in this case, we don't create that blocker of origin. We don't block if it's from the same origin because it's after. Because if it's before in the same origin and we care about it, it's already been transposed. I guess that's the thing. Yeah. Okay, so let's try this now. Let's try moving it right. Still breaks. Yeah, so what happened now? We tried moving it right. We tried moving. First we move this removal right, which worked just fine. And what happened there is that it would it wouldn't wait a minute, that's weird. Why did that first one work? Because we're looking at everything after that. And how does it transpose? It should. No, I'm thinking about this the wrong way, because like 5 doesn't actually. So fuck, this is, god damn it. So when I move 1 over here, I'm saying that I should transpose, like based on moving 5 over here, I'm saying that 5 should be transposed by 8, the removal here. So that when we try to apply the line over here, it's actually applied on line 4, which makes sense. But when I move this removal here over to 1, I'm saying that it should be transposed by this one, which is an addition. But that's wrong. Why is that wrong? No, that's the thing. That's where I'm going wrong. I'm saying that line 8, the removal of line 8 actually affects this one, but it doesn't because it's after, right? So the removal still happens on line 8 here. So this is where I'm going wrong. It's, yeah. So when I move right isHunk after in origin, that doesn't matter. That doesn't matter. We don't even need to check that. For the thing itself, that doesn't matter. Where it starts to matter is when you actually get into the when you're in between the target and the origin, or yeah, and again here, oh yeah, sorry. So here, is it before the moved hunk start, in between, or is it before in the target? That's the only thing we care about. So if I were to move this one, nothing should happen at all. And when I move this one, nothing should happen at all. But it did. Why did it do that? Is hunk between target and origin? Oh. Is hunk shinex more? Is less? And oh, that's also wrong. I didn't change that. But why does it actually transpose that one? Is hunk before in target? Yeah, and again we have to make sure that it's not the same, because that means it's already been transposed. Okay. And now fuck. What the hell happened now? Oh. So that one worked there. Oh, this is even trickier. No, this isn't even trickier. It's just that. No, yeah, that's interesting. What happened there? So let's move these two right. And then this one's perfectly fine, but when I move it over here now, it's wrong. And that means that it has been transposed by, you see that? It has been transposed. How can it have been transposed? Is hunk between target and origin. So this is true. This is not true. So this doesn't hit. And this doesn't hit. So how can it have been transposed? So the start, yes, if the hunk SHA index is less than the moved hunk SHA index. No, it's not less, it's more. How can that cause, how can this one be transposed? I don't quite understand. So we have the transposed SHA index to, yeah, let's just look at the array. Oh, was it already wrong here? No, sorry. Okay. So this one was for some reason transposed. How could that have been? And the only way it could have been transposed is with get move hunk right transpose. You see it has transposed by 1, I guess. Yeah, we should look at which hunk. Where is the transpose by? Oh yeah. So this was the first one, I guess. This was the second. Moved hunk. I'm confused. I'm losing it. Why did it transpose? How is that possible? Transpose. Let's remove all this other stuff. Moved hunk transpose. Oh, sorry. Transpose by. And the thing that was transposed is a moved hunk.id. Oh, that's interesting. It says 0. How can it now have changed to 22? It was 21. It must have been caused by if start is more within the same SHA and up to where it was moved. So this is affecting the other ones. After the current, which would match this 21 to 22. Let's do transpose other. Yeah. Oh, interesting. Transpose. There we go. Transpose other. One 6. So when I'm moving, and then I'm transposing 1 1, and when I'm transposing 1 1, it's actually transposing how can that happen? Oh, because when I so what's happening here is that I'm moving. Yeah, so what's tricky mental game here is like I'm literally moving these two first, and then I go back here and then I move the other one, but I'm actually transposing everything. So it will go in and it would actually transpose this one first. So it would be just like going in here and doing this, and then it moves this one, and then it moves this one. And here you can see it still fails. Okay, but this is interesting. So The reason it did that is because when that is already in there, it means that it actually hits this one. So the show index is actually more, and like it hits this one. And it is actually correct that it should transpose the other. But in this case, it should not do like a -1. Maybe this -1 was a side effect of us doing something wrong previously. That might be. Yeah, because now you see these ones are actually okay now. Yeah, I think that was like a compensator for some other bad logic. So if we move this one now, god damn it. So it should have gotten like -1. So now it went from 21 to 20. What's interesting, it shouldn't move at all. Yeah, something doing it wrong. Because this, like moving this it's not. Now when we actually moved away these two other things, it's not affected anymore. Like when we had it here, it wasn't affected by the previous, like there wasn't anything here. Like here, there wasn't anything, like we had both of these lines and they were previously removed here, but they aren't anymore. So it's just like coming from the old file. So maybe this indicates that transposing should happen in reversed order. Does it indicate that? No, because the same thing would happen, wouldn't it? Or does it? Because if I move this one right over here, now it's not wrong. Why isn't it wrong when I just move it here? Yeah, because now they are actually removed. Or one line is removed, the other one is replaced, so that's why it's one line. So that's actually correct. Yeah, so this is about, so what really should happen here is that, okay, so what if it does move that one first? It gets transposed to line 20. What should have happened, it should be when now these two were transposed, this should be transposed back into 21, which didn't happen. So let's see what happens here now. Yeah, it stays as at 20. So that's the problem. Is when we're moving right and we have this other one that should be transposed. God damn it, he's awake. Oh, I have to finalize this thought. It means that yeah, this should be times -1 because it's the opposite. Like we're not applying the diffs, we're kind of retracting them. But I wonder why it becomes 22 then. Is it this one that's wrong? Because it should go from 20 to 21. That's the weird thing. It shouldn't go to... Yeah, that's the weird thing. It shouldn't go to 22. It should actually go to... Yeah, that's the thing. It should actually go to 21 again. Because there was actually just one removal. So I wonder why... So when we transpose one of them... Oh, it's really bad. Like, I really need to finish this thought. So what happened here originally when this was moved over? It was reduced to 20. Because now the line changes were applied. Like, there was a removal here. But then I moved that removal. Which means that it should be bumped back to 21. But it's bumped back to 22. And that's not correct. And I wonder how that could have happened. It's almost like it didn't keep... transpose other... Or maybe it was it. It didn't transpose -1. Maybe that was the issue. Like there should be a -1 here as well. Transpose 0, 21, -1. This one should be -1. Yeah, that's the problem. Okay. Get hunk right. Get move hunk right transpose. This should be -1. Which I think actually happens when I do this. Yeah, here we get -1. Why didn't we get that on the other one? It's as if it didn't include... No, wait, how does it actually do this? Because now they are actually at a different SHA. Okay, let me just finalize that thought. It's moved right. So they are in the data, they have been moved. So when we try to move that over, yeah, it doesn't apply the -1 because they're already moved. But when we transpose, yeah, this is interesting. But when we transpose those that has been moved, we are transposing what's in there. Maybe I'm just doing this wrong. Like, we can't do that transposition in steps. Or do I have to treat? So when I transpose something, I have to treat it as, maybe that's the thing. So when I transpose the thing I'm moving, I have to move it as if everything is in origin SHA. Because then it transposes correctly. Yeah, as if everything is applied to its origin. And then that causes a transposition to the others. Wow, no, this is... I think I'm doing the transposing wrong. I can't believe this is so difficult. I'm missing a detail here. At least I have something in my head to think about. Jeg kommer straks. Han våken. Okay, what's in my head is that when I move something, like the data structure has changed the SHA index. That's like ready. But when I do the transposing, I transpose like one at a time. So if I move something from, so when I move from SHA index 1 to SHA index 2, and those two existing ones were already moved to SHA index 3, it didn't transpose it because it wasn't supposed to. That was correct. But when it then went to the SHA index that was moved from 1, oh, maybe that's the only thing that needs to happen. I have to do the same. So we only transpose stuff that hasn't been moved already. Would that solve it? Maybe. This is moving left and this is moving right. Only if it has not already been moved. Okay, let's just try that and see, and then I'll leave it with that. Okay, so that worked. Yeah, that actually worked. Okay, interesting. So we only transpose stuff when we move something. We only transpose stuff that hasn't already been moved. So what happens in this case is that we moved something which was then transposed with -1. It was transposed with -1. Was it? I'm not sure about this. I think we're going to hit issues with this. But at least this example is working. I can move all of this stuff around, I think. Yeah, like I haven't tested this. Yeah, that's still working. If I put it here. Yeah, you see that? It starts breaking. Yeah, no, there's a different story to this, that's for sure. Anyways, I have to go. I'll keep thinking about this. How should that transposition story go? Because what actually happened here now? It first moved this one over here. I don't want to even think about this. I think there's a big simplification to be had there. That's my intuition. Yeah, but yeah, we'll talk later. Bye.